The first part of the dipole antenna that I specified was the center insulator. The center insulator is really the central part of the dipole antenna, where the coaxial cable connects with the antenna's radiating elements. So it sees the tension from those radiating elements that are hanging in the trees, and it also sees the weight of the coaxial cable that's hanging down below it. So it needs to be strong, and it also needs to be resilient because it's certainly exposed to the elements, the sun, the cold temperatures, and all those things tend to degrade plastic and tend to make it harder for those things to survive many years of service. So I bought mine from the wireman because I was able to get a good price on something that I thought would last at least a year. And the wireman for me is a local supplier, so I felt good about being able to support him. The next part was recommended by the wireman, and I also bought from the wireman, was a set of wire thimbles. These were recommended because they increase the longevity of wire antennas. It does so by really supporting the loop where the antenna's radiating elements connect to the center insulator. So the connection of that radiating element to the center insulator is just a loop of the solid copper wire. And you can imagine just going solid copper wire through the eye bolt would create a very high pressure point in the wire, and it would make it a lot easier to break that wire, and that wire would be more likely to fatigue and fail. So the wire thimbles increase the radius of that loop and also spread out that force over a greater surface area on the wire. And it really was easy to install. It didn't make it any harder to install. It was inexpensive, and I thank the wireman for making that recommendation because I really do think that it helped make my antenna stronger. The wire that I selected was 14 gauge solid copper wire with green insulation that I found from the Home Depot. So I chose green because green was the most likely color to blend into the trees, even though green in the sky is not necessarily a camouflage color like in the winter. But it's better than red or black or white. I bought two 50-foot rolls of this wire, even though I needed about 60 feet, because 100-foot spools weren't available from my store. I later found that I could order them online, and that would have been better. I would have had, instead of having two short pieces of wire, I would have had one longer piece left over. The stakes that I used to make the insulator at the end of the radiating element, this is the connection between the antenna wire, the radiating antenna wire, and the paracord, which is actually what's going over the tree branch to support the antenna, were just scraps that I found in my wood pile. I cut these to the length that I needed and drilled holes in them. And stakes are super cheap at any home improvement store, and you can probably find scrap wood at a home improvement store that would be suitable. The paracord, which is, as I said earlier, really the thing that's holding up the antenna and allowing the radiating elements of the antenna to be straight as possible, and hopefully as close to collinear as possible. The paracord is used a lot in camping, and I've found mine in the camping section at Walmart. I knew I would be able to get my antenna, at least the ends of my antenna, up in branches about 30 to 40 feet off the ground. So knowing that I needed to go over that branch and back down and be able to hold both sides, because I was going to use the branch kind of like a pulley to pull my antenna into the sky. I knew I needed at least 75 or 80 feet of paracord. So the closest length to that was greater than was 100 feet. So I bought 2 sections of 100-foot long paracord from Walmart. And it's actually still holding up pretty well after almost a year. The last piece was the part that I didn't cheap out on. It was the part that I really splurged on, I guess. It was the coaxial cable that connects the radio to the antenna. The coax that I chose was primarily based on the length that I needed. I knew I didn't want something too short. I knew I didn't want to get an antenna in the air and find that I didn't have enough cable to get to my radio. So I really overbought on the length. I also had a different plan about how I was going to route that cable through my house when I started. So I definitely have too much coax now. I bought 100 feet of DX Engineering's 400 max coax. And I'm very satisfied with it. I think it was very well constructed. The connectors on the ends are soldered on beautifully. It's almost hard to tell that it's soldered. It seems like it's all one piece. And the cable being 400 max is very low loss at HF, and I'm getting good results even though it's a very long run at 100 feet. So this is the final cost tally after I finished my antenna. You can see that the most expensive part by a long shot was the coaxial cable. Everything else was relatively inexpensive. And if I had it to do over again, I would do a better job estimating the length of coax that I truly needed. I would do a better job of talking to some people in my club and seeing if they had coax that I could borrow until I found out exactly what length that I needed. And I would even see if I could maybe get a handout of some coax just to test with and make sure that my antenna was going to work before I went out and invested over $100 in one piece of coax. This is the center insulator of my 40-meter dipole. It's self-supported on each end, and but you can see the coax running down there almost vertically to the eave of my house, where it's hooked into an eye bolt. If we follow the antenna wire, we can see the thin black line. It terminates there at a wood insulator. I just took a stake and cut it off about 4 to 5 inches in length and drilled holes in either end, one side for the rope. You see the rope on the left side, and then the antenna wire is on the right side. The antenna itself is through the hole in the insulator and then twisted back around on itself to get the right length. So there's a little extra length if I wanted to tune the antenna for a lower frequency in the future. Here's another view of the center insulator of the antenna, and you can see the coax coming down to the eave here, and you can see that it runs along the side of the house. It's supported by 2 eye bolts that are mounted to the underside of the eave. This has stayed very secure over almost a year at this point. To support the weight of the antenna, I use one center block on each side that's tied to the paracord that ultimately runs over the tree branch. This cinder block, it's a simple knot that's tied around the middle web of the cinder block, and we can follow the paracord as it goes up to the top of the tree. It gets lost in the tree cover there, but if we turn and move a little bit, we can see the antenna wire in the upper right-hand corner against the blue sky. There's another wooden insulator that's hard to see because of the tree cover.
but it's designed the same way, about 5 inches in length with a hole on each side. So as you can see by the lack of leaves on the trees, it's winter time, and I've just finished an analysis of the antenna using my Nano VNA. This is about 6, 7, 8 months later than the earlier videos that I took. And I think I'm ready, and I think it's time to take this antenna down and to start doing some changes. Mostly shortening the antenna to get its resonant frequency a little bit closer to the 40-meter amateur band, but also raising it and trying to use some more of this tree's height, even though its branches get a little bit smaller, and try and see if we can get a little bit of a lower radiation pattern to talk to some more distant stations, and to see what else we can hear if we raise the antenna and get it a little bit closer to a quarter wavelength high.